So we are going to continue today our discussion on fundamentals of Python. While we're working in Python and little certain details of how things are implemented in Python, the structure of this lecture is similar to any other programming environment. So you have to figure out, well, what are the variables? How do I define them? How do I store things? How do I print things? How do I plot things? So there are certain, like we call those plotting, input, output, variable definition. All those exist in all of the possible programming languages. It's just that we are like looking into how are these things done in Python, so we can actually become well-versed at writing things immediately and solve our problems immediately. So let's get going. Just a quick reminder. So I am kind of updating slides ever so little from lecture to lecture as I'm kind of tweaking the material. So every time I do that, I do upload the new one. So it's safe to say that before every lecture, especially for this lectures 2 and 3, you can go and download the most up-to-date lecture from Canvas. Okay. So that is one comment, and then let me quickly go through to the slides where we stopped. So we are going to continue using Python today, and just note that this lecture is accompanied by scripts that you can find also in Canvas. There's a code subfolder, and you can download these. So most of the stuff that I'm going through the class is also in these scripts as a type of a document. And you can, we're going to get to that, you can execute all of these scripts at all times, even though right now we're focusing on typing things in as we go. So let's actually quickly open our Spider environment, and today we're actually going to get to a different environment just to experience them all. So in wherever your programs are, open Anaconda Navigator, and then from it open Spider. Again, these are just, there is various other environments. This is not the only one. And this is just this Anaconda package is convenient for this class. That's all. There's multiple ways you could do this, but there's Spider here that we're going to use in Jupyter notebooks. Okay? So let's open Spider. Launch. And if you don't have a computer on your own, please work with a colleague. Try not to get online. Close your Facebook account, Instagram, whatever is currently in. Just try to use the time you have in class in a more efficient way. It will benefit mostly you. So this is one of these. There's lecture 2.1 variables and lecture 2.2 vectors and matrices. Those are the two sort of scripts that we're going through. So script is just the name of this file that is really just like a succession of commands. Now you can notice that some of these things are in gray, and they're especially things that are starting with a little, what's the name of this hashtag? Business. So this is not Twitter, okay? This is actually assigned to Spider or to any Python interpreter that this is a comment disregarded. So this is just for humans to read as an explanation. Interpreter is not going to try to interpret this as any type of command, okay? So this is why I'm placing my comments like that. So again, every programming language has some way to type in a comment. It's typically a % or a hashtag or maybe quotation marks. It's one of the above, okay? Slash, backslash operator, okay? So in this particular language, it is this type. So I'm placing comments to let you know what's going on. And then the only commands that are actually executed are the ones that are in actually colors that are visible, invisible versus barely visible. Okay. So just a quick reminder, we can either have things in script and you can execute this script. You can just run, but if I run everything all at once, everything will execute all at once, right? And right now we're focusing on typing things one by one so we can see what's happening, okay? But if you wanted to actually execute this entire script, you would do this, okay? And apparently I have some error down there that I'm gonna get to, okay? But basically it did actually execute everything. So this is all of the matrices that we're actually going to type in today. And we're gonna, again, go and focus on typing them in, but you can execute this script all at once, or any kind of set of commands that you decide to put in a file, and we typically denote those files as .py in Python. In Jupyter Notebook, we're gonna have .pynb, we're gonna get to that. And then I know that this is my set of commands that I can refer to. So again, you're gonna be designer of these files as we go along. Okay, so just for you to know, and it's something that I can go back to, right? I save the commands, I can go back to it, I can see what I had in there, and that's really valuable. Whereas whatever I type in, if I type in things here, A is 4.5, right? A is there, and now it's defined in memory. I can actually find it in my, here it is, A, okay? I can define it in my, or find it in my variable explorer. Let me open up Explorer a little more. Okay. But this command, it's gonna stay here in history for a little more, so I can actually look it up in history log. If you're looking to see what you executed, this is what executed all of the things from the script. But it's kind of fleeting, so that's why it's good to actually save it into a file to actually have that sequence for later. So again, scripts are just there as something that we mean to execute again and want to actually look back to, and you basically put it in a file for that reason. All right. And as we build larger algorithms, it's good to have all of those sequences of commands. You don't want to retype them. Okay, you want to reuse them. Okay, so this is our way to store the commands. All right, let's move on and let's actually continue our discussion about vectors. And today we're going to work with vectors and matrices and how do I actually put them into account. So I mentioned last time that we need numerical Python. It's a module that we add. And the way we add modules is by putting import NumPy is the name of the module. It's already installed with Anaconda distribution, so we don't have to worry about that. It's available. And all I'm telling here Python is to say, well, I'm going to refer to it as NP pretty much because I'm lazy typing. So I don't want to constantly type numpy.this, numpy.that when I'm calling commands. NP is short. Okay? You could also just place a star in there and then you wouldn't have to type anything, but then you're risking that you have a command that you define somewhere else that possibly has the same name. This way we're kind of making those commands unique. So we're going to stick, and it's kind of really common all across the available online literature to import NumPy as NP. So I'm just going to go with that flow because most of the code out there is doing the same. So first thing that I'm telling here, and I'm going to retype this even though I actually executed it already, I'm going to say, hey, C is my NP array. This is a built-in function that is just going to create an array out of numbers 25, 28, 1, 2. So whenever I'm executing a built-in function, I typically inside any function, inside parentheses, I put in what I'm giving that function. And in this case, I'm giving that function this sequence of numbers. And when I say create an array, computer has to figure out, okay, I gotta find space in memory for 4 numbers, right? So it's going to actually go find that space in memory, figure out what the address in memory is, and all those stuff. All we need to know is that this array, for all intents and purposes, is going to be called C. Okay? But NumPy behind it knows where it's stored, how long it is, what is stored inside. Okay? So there's bookkeeping. It's like going to the library and reserving shelf for it. Yes?
Why do we need to use NumPy for the array but not for just numbers A and B?
Because we are actually using NumPy and the way they define arrays, because it's very beneficial for large-scale computation. Okay? So there is a way to avoid NumPy. There's a way to store these numbers in a list, and regular Python has a way to deal with it. One specific place. Here we go. Thank you for asking. Great, cool. So let's create it. What I can now do, okay, I can simply manipulate the entire array, all 4 numbers. Right now it's 4 numbers. It could be 4,000, okay? If I had a vel log, easily in thousands. I can operate on it all at once. So I can actually say, hey, give me 5 times C plus 5.6. I'm coming up with numbers even though my script says do something else. It doesn't matter. Whatever operation you want to do with all of them and print that, it went one by one, okay? And did 5 times element plus 5.6 with element 1, 2, 3, 4. Okay? If I had 40, it would do the same. This is available in numerical Python, is not available in the regular. Okay?
Why did we have to type print?
Print is just to tell it to print. Otherwise, it's going to actually execute it, but it's not going to give you the value.
Why did we have to type print dot np?
Oh, print is a command from Python. So there is no dot. So the operation I did here was actually this. And actually it gives me a result. Print just prints it without this array business. It just prints the values. So it executed this 5 times all of the C values plus 5.6. And that's an array of 4 values. So I can do it without print.
I want to know at what times we need to put np dot before command.
So you have to know the command. So print command is the command from a regular Python that is just available in regular Python, and therefore we don't need anything to do it. It's just print. Right? np.array, this array command, is a specific command from NumPy. So this is actually a great point. This is going to be a little confusing because we're going to go through a lot of commands. And it's good to know a set of them, just know them, so that you can be fast. Start writing a cheat sheet, or maybe just separate an Excel file or a regular file, whatever it is, that is just going to line up all of the commands. And you can grab them either from these files or from the PowerPoint or whatever, but it's like learning a new language. You need a vocabulary, right? So now, print is part of your vocabulary. It's part of the regular Python. It's always available with every Python. np.array, array is a function that is from NumPy, which we call np. Okay? And therefore, I need to give it a full name, np. Okay? There's a lot of Mashas out there. Prodanovic Masha is a more unique one, so it's like my last name. So this np is like adding a last name for more uniqueness. Right? So that way I know that I'm from family Prodanovic. So family NumPy has function or child array. Okay. Does that make sense?
Yes.
So that's simply to fully identify that function.
Where did all those variables come from?
All
All
the
the variables.
this because I executed this. So there's actually a lot of this file. It keeps going, and I actually this is a run command, And I just at the beginning, I just actually executed it. If you don't have it. But we're going to actually go through it down, so either way. Okay? So I was just saying, when you put things in a script, you can execute all at once. But all at once is not helpful if I don't explain to you what you're doing. So, all right. So that's, again, numerical Python allows me to work with the entire array. We're going to refer to that as vectorization. It's really powerful because I can simply write this down. I don't have to actually we're going to get to loops next week. I don't have to go through every element and say, for element 1, do this operation. For element 2, do this operation. 3, 4, 4,000, right? And in this case, just 4. Now, how do we refer to these elements? Okay. The numbering starts from 0. And a lot of times it does. Because 0 really means, so my first element starts at the element address, which is C, or we call it C. Immediately right after that is the first element. So I don't have to move from the name of the element at all. Immediately after I have this first element, which is 0th element in terms of the memory. Okay? And then after first one, then I have a size of that element. There's certain specific size to it in number of bytes, and then it has to skip that many number of bytes, and then the second element starts. Okay, so that's why we refer to them as +0, +1, plus. So my elements are actually 0th element, first, second, and third. When I have 4 elements, so if I want to print the very first element, it's actually 0th element. And I have to use these angular brackets to get to it. So when we're referring to elements of an array, you have to use angular bracket. If you're providing something to a function like this print, then you use curved bracket. We're obviously practicing print here. Here's what I get if I just type in C of 0. So that's fine too. Print is a direct command. Okay, print this without any extraneous things. And in this case, I didn't have anything else. So it prints out either way. There's a hack to get to the last element, which in this case, it's element 3. I have 0, 1, 2, 3. So for 4 elements. But you can just say, if you don't know which one it is, you can just say C of -1. That's 2. And if you forgot what C is, this is the entire array. Okay? So there's just a hack to get to the last one. The second to last would be -2, and you can keep going into negatives. Okay, let's now move on to the matrices. So we have vectors. Vectors are these 1D arrays. Actually, let's do an exercise before that. Let's work with vectors. So one thing that we had is angle between 2 vectors. Okay? And the way we defined it is a cosine of theta between 2 angles, 2 vectors u and v, is u dot v dot product, or scalar product between 2 vectors, divided by their norm. Now, there's first definition is in terms of matrices, okay, when I had to transpose, and you had that exercise in your homework. And I believe there was a little bit of confusion, well, when do I use which one, and which one is defined and when? Okay. Well, the first one requires you to view vectors as matrices. So vector is either a column vector, therefore sort of a trivial matrix with only 1 row, or it's a column vector, which is a trivial matrix with only 1 column. But I do view vectors as having rows and columns. Not everyone subscribes to that view. In mathematics originally, without embedding them into matrices. Vectors and vectors are just an array of numbers and they don't have the second dimension. Okay, so I have only one dimension and a sequence of numbers in that dimension. And Python subscribes to that view. In which case we actually just need to use dot product. So as long as those two one-dimensional objects have the same number of elements, I can actually do a dot product on them and take first element from the first one, first from the second one, multiply, then add to the second times second plus third times third, and keep going. So let's define, so as an exercise, using that np.array, define these vectors u and v in your Python command line. One of them is -2, 1, 3, and the other one is 3 on 2. So those are two vectors in 3D. They have some direction, and they actually form a plane, and in that plane I can look at the angle between them, right? The cosine theta of that angle is given here. So let's first define them. And I'm gonna wait, I'm not gonna, you're supposed to do that on your own. Okay. So it's np.array is your function that is going to create those two objects. And let me know when you're done defining u and v. And if you have trouble, let us know. Rui is silently sitting behind. If you need help, he's available. Has everybody defined u and v? And it's okay to make mistakes. Actually, if you don't make mistakes initially, you will never gonna learn. Common thing to forget is to forget this np.array, or not to import. Did you import numpy as an np? That's the first step. If you didn't execute that script, it didn't get imported. So first you have to tell it, hey, by the way, use numpy. And then u is np.array. First mistake you could do is to use wrong brackets. So curved brackets when I'm providing some input to a function, yes?
How often do we have to put import NP?
Once per session, open session of the, yeah. If you close it down, and I had it closed down because I had to reboot my computer this morning. So when I open it up, I gotta do it again. Okay. So it's, and you still have issues with finding? Somebody has a problem with NP? Rui, if you can walk around. So what did I say? It's -2, comma 1, comma 3. It does want those commas separating numbers. If you don't enter them, you're going to have issues. And there has to be angular brackets around the sequence of numbers I'm giving it, so it knows that that's one input and not multiple. So this is my u. I can just say u and it's going to print, or I can say print u and then it's not going to put array around it. Cool, so that's my u. My v is, can somebody remind me what numbers were?
3, 1, 2.
3, 1, 2. So now I first need a dot product. I could do it myself. Okay, so I could just say u of 0 times v of 0, which multiplies first elements in each array, and then plus u of 1 times v of 1 plus u of 2 times v of 2. product, right? So I know how to do that already. I need to know how to refer to the elements of the array, and what I need to know specifically is that it starts from 0. Okay, I simply have to know. And so and the rest is I have to type things in correctly, which can be a problem. That's apparently 1. There's actually a pre-programmed function that can do this on a vector of size 4000, which you don't want to type in yourself, right? We would be here typing for 2 hours. And that is np dot. So NumPy has a dot product. It's implemented as function called dot, dot. I have to tell it it's in NumPy, np dot, dot, okay? Or np dot, dot of u and v. So this function, and it's a built-in function that is available to us to use, takes in 2 inputs, which are 2 vectors, or 2 one-dimensional arrays. Boom. Apparently I did my calculation right. They agree. So I also verified that, well, this dot product that is implemented in NumPy apparently does the same thing as this, okay? At least on this example. So that's my dot product. There's also norm function, and this one has 2 last names. How many of you have two last names? Nobody? There's 1 person with 2 last names. Cool. So this is going to be np dot ALG, which is linear algebra. So there's a subset of functions called linear algebra. Dot norm of u is norm of vector u. And specifically by default, this is a 2 norm. And I can do the same for v. So again, if I had a spreadsheet that I was collecting all of the functions we defined, I would put 2 new ones, np.dot and np.linearalgebra.norm. And they're also available in your slides. Okay, so they're right here. So let's now put them together and actually do what is cosine theta. And I'm literally going to call that variable cosine theta, like that. You can use cut, copy, paste, divided by these 2 norms multiplying each other. What? Oops. So that's my cosine theta. Because it assigned it to a value, it didn't print it out, but I can find it here in my variable explorer, or I can just say print cosine theta.
The instructions on Canvas, I can't see.
This is difficult to see?
Yeah, are the instructions on Canvas?
These particular ones I'm typing in right now, but what I have as suggestions are here. Now, what I'm going to do is attempt to change my preferences to get a little larger font. Let's go with 20. better? All right. Do I need better? Last row, do you see? Soon enough, the class will self-segregate to nearsighted to farsighted people. With 2020s in the middle. Okay. I'm laughing, but my vision is really poor. So it's funny and it's not funny. All right. Okay, so now I have cosine of this angle. I need an inverse cosine. And I could go to tables, I could go to calculator, but these things are again built in. And they're actually built in numerical Python as well. And I'm going to flash an entire list of functions. Okay? An entire list of, it's in my slides, that is actually available, which is just a sublist. Oops. On mathematical functions, it's from one of the more advanced slides. Okay? Sine, cosine, tangent, hyperbolic versions, exponential, logarithm, and so forth, and much more is available already. So if it's a mathematical function that you've used in your calculus class, it's available already. Your job is just to look it up. Will I ask you to know all of them? No, but sine, cosine are just the way you would write them in your math class, so there's not much to know about it. Okay? Now, what is inverse cosine? It's probably a cosine, but it's a good question. Okay? So I'm going to actually give you a quick Googling task. Google NumPy, arcus cosine or inverse cosine in NumPy, and find for me, how do I find inverse cosine? So that function is not this, but that's how you help yourself. Again, if it's a classical mathematical function, it's out there, it's already, somebody has already implemented it, you just need to figure out how to use it. So it's np dot what? Is it a cosine arc? Let's try. You can always just try. That works. I could have just tried. I would expect a cosine, and it says, hey, there's no such attribute. But this one exists, and it's 1.49. Is this in degrees, or is this in radians? Looks like, do we know what radians are? 180 degrees is the same as pi, 3.14 in radians, right? If I need help, how do I ask for help? I could Google it and find a web page that has it, or I can just ask help. This is lengthy help, but nevertheless, it's all there. I gotta scroll up. To the beginning of it. To the very beginning of it. And that's a long beginning. Apparently, I do need to go to online because this is too long. But basically, it looks like it's radians, and this can give you help on the function, or you can go online and see what the definition is. Maybe more readable version is online. NumPy, hard costs. There we go. Okay. Important thing is you can actually put it as an array, like you can give it an entire array of values. Okay. And it's an inverse cosine element wise. Is there a way for me to convert it to degrees? Doesn't seem a direct way, so I would have to convert, though probably there's another function that returns degrees, okay? So you can find help in various places. If something is logical to have been defined, it probably has been already, okay? Cool. Let's move on. So these are our 1D arrays, and we'll exercise on vectors or 1D arrays. Now we're gonna actually move on to matrices. I'm going to explain through the PowerPoint. You can type in. I'm going to type in later. So if I wanted to type in a matrix, I would give it NumPy row by row in little angular brackets. So here, if I wanted a 2 by 2 matrix that has 1, 2 in first row and 3, 4 in the second, I would again say np.array. I have to give it idea that it's a 2D matrix. I have to have 2 sets of angular brackets. Otherwise, it doesn't know that it needs to arrange a matrix out of it. Okay? If you just give it 4 numbers, those 4 numbers could be in arrangement 1 times 4, 2 by 2, 4 times 1, right? So in order for it to know, you have to give it row by row, everything separated in angular brackets. So let's do that. Let's type in. And again, it's available here in the script. You can copy it over, but by copying it over, you're not going to learn how to type it yourself. So it's good exercise to type it yourself. But again, if it bothers you right now for following the class, you can just copy it over. Work at your pace. So NP array, the way I do this, I first put brackets around input to the function. So those are the curved ones. Then outer ones for the entire to the array. And then each row is written separately. That's how I go and make sure that I have all of the brackets in place. So outer brackets for providing input to the function. Then outer angular brackets for the array, and I have to make sure that array is a 2-dimensional one, so each row is given separately in its own set of angular brackets. And by the way, the environment here is actually giving you help. So array function, there's this object that I'm passing. I could apparently have numerous different arguments that I'm not providing right now, and the function can survive without them. It just works with default. Cool. So my A is defined, and it shows up here. It's 2 by 2. Okay. Can see that. It's defined as integer 64. We are going to get to that, but it's actually 64 bits or 8 bytes reserved for this integer. Why did it decide to do so? I don't know. It's a lot. And if I want to print it, I can just do A. If I do A like this, then it's going to have that array that I don't like printed. Either way, it's 1, 2, 3, 4. I can now do again all of the operations on the entire matrix, which is really cool when the matrix is large. So I can just do 5 times A, and it's just going to do 5 times every element in this matrix without me typing it separately. Okay? So 5 times A is obviously 5, 10, 15, and 20. You can do cosine of A, but cosine is not a regular function, it's a numpy function. And you could do cosine of it. Okay? So whatever it is that you wanted to do, you can do on entire, and this is why we're using numpy. We can define a larger matrix. Let's do that just for practice. So for this one, I just want to have the way we were labeling matrices, 1, 1, 1, 2, 1, 3, 1, 4, the elements. Let's put that as elements of the array. And we're going to have 3 by 4. Okay? So I'm going to redefine my A. So first row is 11, 13, 4. And then comma, second row, 2, 1, comma, 2, 2, comma, 2, 3, 2, 4. And then third row, 3, 1, 3, 2, 3, 3, 3, 4. It didn't like something. What did I mess up? Oh, one bracket too much. Okay. I was overzealous in typing in my angular brackets. And then if I want to print it, here it is. So now I have a two-dimensional array, and to get to the elements of that array, I need both row and column information, and I am starting from 0. So my very first element, what in linear algebra we refer to as 1, 1, this is why I'm calling it 11 here, 1, 1, it's A of 0, 0, so I gotta reduce by 1. So this A of 0, comma 0 is 11. Okay, so that's this very first one. So again, I gotta give, every time I'm asking array, give me one of your elements, I'm gonna give angular brackets. If it was 1D array, I would just provide one number. If it's 2D array as a matrix, I need two numbers, and I'm going to separate them with a comma. If I had 3D array, which I could, 4D, 5D, computer can handle it. I don't know that our brain can easily do 5D array. Okay. Or visualize it. You can just keep adding these. Okay. So 0, 1 is which element in this matrix? It's printed up there or printed here. Row 0, right? And 0, 1s, so basically 1 less than this, so it's 12. So it's a little unfortunate that this labeling is off in linear algebra versus here. It's what it is. That's how this implementation works. And half of the programming languages start from 0 and the other half starts from 1. So when I start referring to 1, 1, is that because MATLAB starts from 1 and Fortran start from 1. So depending which one I use more at any given time, that's what I'm used to using. Gotta switch. Okay. Those are conventions. All right. All right. I can also have some shortcuts to actually grabbing an entire set of variables. So if I actually try to do 0 through 3, it's going to start from 0 and give me everybody less than 3 as far as row information goes. So basically there will be 3 elements here. A0, 0, A1, 0, and A2, 0. Okay? So the 0, 3 is a range from 0 up to 3, but less than 3. And you can also store this in a separate array if you wanted to. Now note that this is actually going down the 0 column, right? And we would normally expect a column array, except that Python, in terms of 1D arrays, doesn't care. It just grabs those values and throws them into a one-dimensional array, which is always shown as a row. So these are actually 1, 1, 2, 1, and 3, 1 right up there. Okay? So it's these 3 values. Because this is 0, 0, 1, 0, 2, 0. Yes? And those are values 1, 1, 2, 1, 3, 1. And I have all of this commentary here in gray that I'm talking about. And you can actually just, this in particular, if you just want entire row or a column, you can just put shortcut like this. And let's actually go for the second column. Those are 1, 2, 2, 2, 3, 2. And I can do the same for values in my, I can go, this is row 1 is the second row essentially. And that is 4 numbers. So I can put column, this column notation kind of goes instead of a range of values. And when I just put column, then it means everybody in the given row or column. So it's just a short hint. You can still, if you would like to, just keep it, you know, give me 0, 1, 2, and 3, and that's the same thing in this particular case. So all of the linear algebra that we would expect is there. So transpose of a matrix is np.transpose. So NP again means that this is the implementation in NumPy. And transpose of a matrix just flips the matrix. So now what used to be a row is a column. I can inspect shape of a matrix either here in variables. Is it 3 by 4, 4 by 3? In my script, I stored this as a B. Just give me a moment. You can say B shape. And that gives you that it's a 4 by 3. If you didn't have this variable explorer or if you needed to grab those values for some reason. Okay. And we're going to learn the matrix multiplication then first thing next time. Okay. So again, the point of using NumPy is that there's all of these handy linear algebra operations that are programmed, and there's a lot of things that are just available to us. We did our review, so we just now want to use it and use it efficiently. And we can use that using this module NumPy. All right, I see you next time on Friday at 2 o'clock.